Have you ever wondered what it takes to make the air in a room so clean that you can manufacture life-saving medicine in it? Well, we're about to go on a fascinating journey. We're going to follow a single, tiny, invisible particle of air as it gets transformed from just, well, ordinary outdoor air into something extraordinary. We're diving into a world that's absolutely critical to modern medicine, but one you've probably never seen before.
So that's the big question, right? How in the world does that happen? How do you take the air from right outside your window, full of dust, pollen, car exhaust, microbes, you name it, and make it pure enough for these hyper-sterile labs where our most important drugs are made? It's a pretty amazing process. And the answer is all inside this incredible piece of engineering, the Air Handling Unit, or AHU for short. This diagram you see here, this maps out the entire journey. We are going to follow one little particle of air starting way over on the far left, take it all the way through this entire system until it finally gets deployed into a sterile clean room on the right. Okay, so the first part of this journey is all about preparation. You can think of it like basic training. This is where the raw, messy, outside air gets its first taste of discipline, its first round of conditioning before the real challenges begin. So right off the bat, our air particle has to get through 3 quick steps. First, it's got to get pulled into the system. Second, it has to pass an initial line of defense. And third, it gets mixed and conditioned to get ready for the tough journey ahead. Let's see how that works. And it all starts right here. A motorized louver opens up, and a big fan starts pulling that fresh air into the unit. This is the very first step of its big transformation, from the chaotic outside world into a super controlled environment. Immediately, that air hits what are called pre-filters. Now think of these guys like bouncers at a really exclusive club. Their job is simple: stop the obvious troublemakers. We're talking the big stuff: dust, bugs, pollen. They get rid of all that, so the more specialized systems down the line can focus on the really tiny, microscopic threats. Right after that, it passes over the cooling coil. Now this part is really clever because it does 2 crucial things at once. First, it cools the air down to the perfect temperature, but it also helps save a ton of energy by pre-cooling some of the air that gets recirculated. It's this brilliant piece of efficiency that also helps control humidity. Very cool. So, our little particle of air has made it through basic training. It's definitely cleaner, it's a lot cooler, but its most demanding challenge, the one that will decide if it's truly pure enough, is still just ahead. And now for the main event. Welcome to what I like to call the elite gauntlet. This is it. This is where pretty good air is made practically perfect, and it is the absolute heart of the entire purification process. Before we even look at the filter, I want you to just look at this number. 99.97%. Burn that number into your brain because it is the key to absolutely everything. So what is that number? That belongs to the HEPA filter, which stands for High Efficiency Particulate Air. It's engineered to be 99.97% efficient at grabbing particles all the way down to 0.3 micrometers in size. I mean, that's unbelievably small. It's basically a maze of fibers, where larger particles just slam into them, medium ones get snagged as they pass by, and the absolute tiniest ones, like viruses, move around so erratically they're bound to get caught. This is where we go beyond just cleaning dust. This is about achieving total sterility. And this diagram just shows you the sheer scale of it all. Look at these sections here. The air gets pushed by a really powerful fan, forced through these huge banks of HEPA filters. For any microscopic contaminant trying to get through, it's like trying to navigate an impossibly dense, impossibly complex maze. There's almost no way out. And yeah, very, very few unwanted particles ever complete that journey. After making it through that gauntlet, what comes out on the other side is literally some of the cleanest air you can find anywhere on Earth. But hold on, the mission's not quite over yet. Being pure is one thing. Staying pure and actually protecting the room, that's the final and kind of genius step. Let's check it out. You see, it's not enough to just pump ultra-clean air into a room. Think about it. What happens every time someone opens the door? All that less clean air from the hallway is going to try to rush in, right? Well, the system has a very clever solution for exactly that problem. And the solution is all about pressure. It's actually pretty simple physics. The AHU works to create a slightly higher air pressure inside the clean room compared to all the areas around it. And as we know from science class, air always flows from an area of higher pressure to an area of lower pressure. And looking back at our diagram, you can see how this all comes together. When that super pure air is supplied to the clean rooms, it creates what's called a pressure cascade. What that really means is, anytime a door opens, the air flows out of the clean room, not in. It actively pushes any potential contaminants away. It's like a constant invisible force field protecting the entire sterile environment. It's brilliant.
So there you have it. Our little particle of air has completed its incredible journey. It was captured, cleaned, conditioned, purified beyond belief, and then deployed as a protector. But why? Why go through all this trouble? Let's talk about why this all matters so much. Honestly, the stakes here could not be higher. This whole incredibly complex process is what prevents a single stray microbe from contaminating sterile medicines. Think about things like vaccines or chemotherapy drugs. It's what ensures the drugs we all rely on are both safe and effective. At the end of the day, it protects patients. And without this kind of technology, modern pharmaceutical manufacturing just wouldn't be possible. Period.
And that really is the bottom line, isn't it? Every single louver, every filter, every coil and fan inside that air handling unit is meticulously designed, built, and calibrated with one single critical purpose in mind: keeping people safe and healthy.
So we've seen how this incredible technology creates these invisible force fields to protect the very medicines that protect us. It kind of makes you wonder, doesn't it? If we can create perfectly pure air for making drugs, where else in our lives, our schools, our hospitals, even our own homes, should this level of protection be the standard? It's definitely something to think about. Thanks for joining me on this journey.